So continuing on with our nested iteration example, this one, again, I'm putting the most emphasis on because this is where students struggle. So if you're going to be watching any videos, I highly recommend these. So, right, and again, we've got this this over here, this visualization will probably help you a great deal if you need it, because you'll be able to see the values of I and J as we go over them. So our ultimate goal with the image processing is that we're going to visit each pixel and then we're going to do something with them. And it's typically going to look like this. For each row, and then for each item in that row, specifically, so we're going to go down, we're going to look at a row, and then we're going to go across the columns in that row. So for each row, so basically the outer for loop is going to go over the rows, and then the inner for loop is going to go over the columns. So we're going to currently look at what's something called making a negative image. A negative image is that basically every pixel is the opposite of what it is originally, right? If we look over here, negative images, right? Then we will see a negative in photography, right? Color, positive picture, and A, B, the negative. So basically from this to this. So that's a very simple transformation to do, relatively speaking. In the red, blue, green, what does opposite mean? It means the difference between the original value and 255. So if your original red was 50, then its opposite is going to be 255 minus 50, so 205. So if you have a lot of red, you're going to have, initially, you're going to have very little of it. And if you have very little red, you're going to have a lot of it. So, and this is what was running over these images, right? This is the negative of the image that was running. This was just running in the background. So what we're going to do is that let's go ahead and try getting this on my computer. Now, again, to install the thing, refer back to the previous video, but I would highly recommend using it on your web browser. But for the more adventurous, because I want you to have that option, right? You can use pip, the Python installer, which would have been installed when you installed Python, to do pip install C image. That is the library that they are using. And then from there, you can test import image and see if that works. So let's go ahead, and I'm going to comment this out so we can get to work. 3 minutes in, we should probably actually get some image processing done. So import image. All right, and now I'm going to go ahead and throw this onto the other side so I can have it as a reference. So let's go ahead and create our image. So let's go ahead and actually test this. Okay, okay, it worked. Says, hey, I don't know what this is, but Python seems to be fine with it, or rather my Python seems to be perfectly fine with it. So image.image is how we load up, or rather image.image. So the image from this is how we create an image or load up an image from our library. And I named it, so what's very important is that I went ahead and put it in the same folder as my code. This is very important if you're again, you can ignore this if you are working in the web browser, which if you have issues, I highly recommend you do that. But I went ahead, and yes, I know you can't see what I'm doing, but in ITP, right over here, I have the image, and I have this shocked.py in the same folder as this. They've got to be at the same folder, got to be in the same place at the same time in order for this to work. So let's go ahead and do pika.png. Now the dog wants to go down. Did I just not do anything good enough for you, puppy? Okay, so dog is downstairs. Let's go ahead and run this. Did not crash. Now, had I misspelled it like awesome.png, I would have gotten a file not found error, one of the most common and annoying errors. So if it's not in the same folder, or you didn't get the name right, and you need to put the file type in there. So that creates it. Let's go ahead and store it in a variable called img. Not too important there. Let's go ahead and see what we do here. So I'm just going to follow this along. Image window, and we'll see what this does. Okay, that came up. We saw something flash on the screen. Let's say image.draw. Okay, came up. Okay, and let's go ahead and say, and then there was a last line here that I'm going to play with. So this simply says create a window for our image. It's going to be the same size as our image. And now draw the image, I'm betting. And then exit on click. So there's our surprise Pikachu. Awesome. So now let's go ahead and remove image.draw. We can see that if we don't do that, it just comes up here, right? So that's what the image.draw. The image.draw actually loads up our image. Okay? That's pretty cool. So what we've got here is we've got our, let's go ahead and see, trash. Okay. So what we've got over here is we've got our image file. We've got, this says create a window for it. It's going to be the same width and the same height as the image. And I want it to be, and then let's draw it. So now let's go ahead and, let's see, there's one more line here which says set delay 115. Not really sure what it does, except it says that set delay 0 will turn off the animation. So let's go ahead and first just show how we can iterate over this. So for every row in range, image.get height. Remember, get height is getting the height tells us how many rows there are, rows from top to bottom. For row and range, so this is a number, and it will give us the number of rows that will go 0 to that many. For column in range, image dot get width. Columns go across. Now we know that they like to do XY coordinates, so that's going to be the column first, then the row, which is completely annoying. So I'm going to say, hey, so I'm going to actually change this up from what they do it. I'm going to call it X and Y. So X coordinate and the Y coordinate. Actually, wait a second. No. Yeah, actually, so if we're going through the height, it's going to be the Y coordinate, and then the width going across is going to be the X coordinate. Right? If it goes across, it's the X. Same as traversing across the columns. It's just that row column gives you kind of the opposite orientation as X and Y. It's one of those weird things that you really haven't had to think about. So let's go ahead and say, hey, let's get the pixel for this specific spot. P is equal to image dot get pixel. Column, let's go ahead and say, and it's at X, Y. Now the reason, again, now a lot of applications you might do X, Y, X and Y might be reversed. It really doesn't matter for this case, but this is the way that it orients and makes sense for me. Okay? So otherwise you can do what they're doing in the book. And let's go ahead and instead make, you know what? We don't need to get a pixel right now. What I'm going to do, for a simpler example, is I'm going to go ahead and say image dot, I'm going to go ahead and say new pixel. So I'm going to create a new pixel to go in that location. It's equal to image dot pixel. Am I going to put a quiz on this stuff? No. This is just a good teaching tool, I think. I knew somebody was just thinking that. Yeah, specifically it was Jonathan. You were thinking that, and if Jonathan was indeed thinking that, I bet he's going to have his mind utterly blown. But, that would be awesome. Anyway, image dot set pixel. So we're going to say, hey, image, new red, new green. Don't follow what they're doing. You haven't created a new red, a new green, and a new blue. So here, I'm going to set up the intensity to full intensity on all of them, which according to this, RGB would make it completely white. So we want no intensity, so it will be black. Okay, set pixel X at the XY coordinate. Then pixel, instead of having its old pixel, is going to be the new pixel. And then what are we going to do? Well, actually, let's go ahead and if we just round this now, it shouldn't do anything for us. Image object has no attribute pixel. Ooh, this could be messy. Oh, right. It's image, the library. Okay. It's not really going to do anything for us because, okay. Set delay is not implemented in this function. To animate your code, put draw when inside your nested loop for the same amount as the inner loop. Intended the same amount. So that's okay. So it's saying that we don't use set delay. If you want to do it, then we can just, then basically what you want, if you want to make changes to this, then we need to essentially draw it. So we're going to draw it every time we complete a row. And what are we going to be drawing? So notice how it's going blue. One row at a time. One row of pixels at a time. Mr. Ash, I don't feel so good. All right, 0, 0, 0. Let's go ahead and stop this. Okay. Right, memory error. Okay, interesting that happened. Maybe it was because I tried doing stuff, whatever. Okay, so let's go ahead and now, but basically what we're doing over here is we're saying, hey, let's create a black pixel now. It was blue last. And then let's say image.setPixel. And then if I put the image.draw here, each time we change the pixel, it will update it. No such thing as pika.png. Let's run this over here. That should be fine. So now you can see a slow little bar. It's very hard to see. You'll probably have to get really uncomfortably close to the screen. Really, really uncomfortably close. You know, I really should like clap my hands and surprise you now, but that would be mean. And I don't know what might break. Interesting. What was that went on? Photo image. Not enough free memory buffer for free memory, so I used too big of an image. Let me go ahead and replace it with a smaller, less high definition Pikachu picture. Okay, so pause the video. Alright, much better. Python should probably not, or this module should probably not be used for professional image editing. So there, that's much quicker. We can see how it goes by one row at a time. I updated this to indent it out, one row. Now here, if I put this here, whoops, we'll see that it goes pixel by pixel and turns it black. You can just kind of see it working very slowly, but I'm not patient enough for that. Okay, so now let's go ahead and talk about the negative. To create the negative, we need to figure out what the original values were for red, green, and blue. So we can do that by getting the pixel and saying, hey, for that pixel, let's get a new red. R is equal to pixel dot get red. Specifically, what we're going to want to do is that we're going to want to take 255 and subtract it. That right? So this gets us the amount of red, and to get the inverse, the negative, not the inverse, the negative, we take 255 and subtract what value is. And so the more red you have, the less you're gonna have. And the less red you have, the more you're going to have. So now we just do that for, whoopsie, let's go ahead and do that for blue. So insert doesn't work. Green, get RGB. So This should have been there. Red, green, blue. So now red, green, blue. And now what I love is that about this is that we can go ahead and run this and we get our negative image. And we get a very shocked Pikachu, amusingly. All right. But the idea here is that for every row, right? We go through each item in the row, each pixel in the row, each XY coordinate in the row. And then so for all the possible Y values, we go through the XY, we go through each of the XY values. And do that. And basically get a new pixel and create that new pixel and say, hey, you know that pixel you had, replace it. And it only modifies it in memory, I believe, right? I'm not writing a file or anything. So yeah, just memorize, it just modifies it in memory. So yeah, so nested loops are one of those things that you only really can understand via practice. I can go over more examples, but really you're just going to have to practice them. A great way to practice them is by using this, going through this textbook and messing with turtles.